Today we are learning about variation and problem solving. I know I've got this when I can solve problems involving direct and inverse variation and differentiate between direct and inverse variation. Direct variation, y varies directly as x, or y is directly proportional to x if there is a non-zero constant k, such as that y equals kx. The number k is called the constant of variation or the constant of proportionality. Go ahead and pause and write these two things down. Make sure you label it direct variation. Number 1a says, if y varies directly as x, find the constant of variation in the direct variation equation given that y equals 5 and x equals 30. All right, we know that y equals kx in direct variation, which means that k equals y over x. Well, you have here, find the constant of variation. So k equals y is 5 and x is 30. And if I simplify that, I get 1/6. So then it wants me to write the direct variation equation. All I have to do is plug what I found for k in the equation. So that is my equation, and that's the constant of proportionality. One B, if y varies directly as x, I like to write this down as I'm going, and y equals 48 when x equals 6, find y when x equals 15. Okay, so if you know that y equals 48 over 6, k, that means k equals 8, so I can write this. Then it says, then find y when x equals 15. So I plug 15 in for x, and I solve that, and I get 120. Write a direct variation equation, y equals kx, that satisfies the ordered pairs in each table. Okay, again, we know that k equals y over x, so all these are constant. So k would equal 5. So the equation is just y equals 5x. When D says if y varies directly as x, this is one for you to do. And y equals 24 when x equals 3. Find y when x equals 6. You should have gotten y equals 48. Okay, here's one more for you to do. Okay, and you should have gotten that k is 2/5, so y equals 2/5 x. All right, so you can pause this and review on direct variation. Okay, now it says the line is the graph of direct variation equation. Find the constant of variation in the direct variation equation. All right, again, if you reviewed that last slide, direct variation has to go through the origin. Okay, so the direct variation constant is the same thing as the slope. Okay, so if you start here and you go up 6 over to this other point that we have, so that's 6 over 4. And you can simplify that to 3 over 2. So the constant variation is 3 over 2, and the equation is y equals 3 over 2x. There's some information on inverse variation. Inverse variation, y varies inversely as x, or y is inversely proportional to x. If there's a non-zero constant k, such as that y equals k over x, therefore the number k is still called the constant of variation or constant of proportionality, and k equals x times y. So pause this please and write that down. Okay, so y varies inversely as x. find the constant of variation k in inverse equation given that y equals 63 when x equals 3. Okay, so we know that this is the inverse variation equation, and we also know that k equals x times y in inverse variation. So 63 times 3 is 189. So if I want to write that equation, I just put the k over the x, and that's my answer. So you can see how this is written. Go ahead and pause that and read. Okay, so now we're solving a problem with this. It says the surface area A of a cube A varies directly as the square of its lengths, of a square of a length of its side S, sorry. So that is how you would write that. So it varies directly, which means you're going to multiply k times whatever they said. So it varies directly as the square of a side, basically. Okay, so if A is 54 when S is 3, we have to find k first. So I get 54 equals, that would be 9 times k. Divide both sides by 9, you get k equals 6. So find A when S is 4.2. So you go A equals k s squared. And when you do that, let's see what you would get. You would get 105.84. Whoops. So you can see how I did all that. And then this side does it every step by step for you also. Okay, here's one for you to do. Go ahead and pause it. Okay, it says the maximum weight that a circular column can hold is inverse. So the weight is inversely proportional to the square of the height. If an 8-foot column, so that's the height, can hold 2 tons, K would be 128, right? And then how much weight can a 10-foot column hold? So 128 over 100, the weight would be 1.28 tons. And that's how you should have done it. Okay. Okay, 2E says Kathy spends an hour and a half watching television and 8 hours studying each week. If the amount of time she spends watching TV varies inversely with the amount of time she spends studying, find the amount of time Kathy will spend watching TV if she studies 14 hours a week. So, okay, so the time she spent varies inversely, and it says she spends an hour and a half watching TV and 8 hours studying. So if I'm solving for K, I would multiply and I would get K equals 12. Okay, so the constant of variation equals 12. So if she studies, how much time will she spend watching TV if she studies 14 hours a week? And the time would be 0.86 hours. Or 52 minutes. Okay, here's some extra practice I want you to try, so go ahead and pause it. And then check your answers. Let me know if you need extra help on this. So I know I've got this when I can solve problems involving direct and inverse variation, differentiate between direct and inverse variation, but do you really understand? How does a direct variation equation differ from an inverse variation equation? Here's a possible answer. In a direct variation equation, as one variable increases, the other increases. In an inverse variation equation, as one increases, the other decreases. If you know a pair of values belongs to an inverse variation, how can you find the constant of proportionality for that relationship? So how can you find k in inverse variation? And basically you would multiply the two. So use the equation y equals k over x, substitute the pair of values for x and y and solve for k. You would multiply x times y to find k.